if a carbonyl compound, such as a ketone, with an alpha hydrogen or a hydrogen of the alpha carbon is treated with catalytic acid or catalytic base, an important reactive intermediate is formed. That reactive intermediate is called an enol. Let's draw a scheme for this, and then we'll see how is this possible. How is it possible to convert a carbonyl compound such as a ketone with an alpha hydrogen into the corresponding enol, and what is special with enols anyway? Why are we interested in them? So what can we do with them in terms of their reactions, for example? So this is the general structure of a ketone, and remember this position is called the alpha position. So this is the alpha carbon. What's important here is the presence of a hydrogen on this alpha carbon. Now, if this ketone is treated with catalytic acid, such as HA, for example, HA, an enol is formed. Now, that's the structure of an enol or enols in general. This is of course, the word enol. If you look at this intermediate or this structure, it has a carbon-carbon double bond. Therefore, it is an alkene. So thus ene, if you like, ene. So it has a carbon-carbon double bond. Therefore, it is ene or alkene. The suffix of alkenes because they have the carbon-carbon double bond. Now, this structure is also an alcohol. So it is an alcohol, so therefore it is all because it is also an alcohol. So thus the suffix all. So it should therefore, the name of this structure or this intermediate should have ene and ol as a suffix. So that's why it's called enol, enol. Therefore, enol, just to indicate that the structure or this intermediate contains a carbon-carbon double bond and of course a hydroxyl group. So therefore, the name of this intermediate is enol, ene because it contains a carbon-carbon double bond, and of course ol because it contains a hydroxyl group. Therefore, it's entitled to be an alcohol. Now, enols are very interesting because they are reactive intermediates. We will see their reactivity shortly. Now, that's one method for the transformation of a carbonyl compound with an alpha hydrogen into the corresponding enolate, an acid catalyst, or we can actually react the carbonyl compound with an alpha hydrogen with catalytic base of this general structure, catalytic base. So there is therefore acid catalyzed enol formation and base catalyzed enol formation. We will work out mechanisms for both methods for the formation of enols from alpha carbonyl or from carbonyl compounds with an alpha hydrogen. Now, what is interesting with enols is that they are reactive intermediates. So enols are actually reactive intermediates. They are reactive intermediates. They are reactive because they are nucleophilic. Now, if you look at this enol structure, of course, there are two lone pairs on that oxygen. We can take one of the lone pairs to make a double bond between oxygen and carbon and simultaneously break the carbon-carbon double bond. And if we do that, we get another resonance form, which is this one. And now if you look at this, that alpha position, this is the alpha position again. That's the alpha carbon. That's the alpha carbon. There is now a carbanion on this alpha position. So this is a carbanion. If it is a carbanion, therefore that alpha carbon is actually nucleophilic. So this alpha carbon is therefore nucleophilic. And that's exactly why enols are very useful reactive intermediates, because they are nucleophilic, and they are nucleophilic on the alpha carbon. This carbon is nucleophilic because now, according to this resonance, we can leave a carbanion on it. So that's why enols are therefore reactive intermediates, because they are nucleophilic, and they are nucleophilic because of this resonance, and they are nucleophilic at the alpha carbon. So therefore, we can take a carbonyl compound such as ketones, which have an alpha hydrogen or a hydrogen on the alpha position. We can take them and transform them into useful reactive intermediates such as enols if the carbonyl compound is treated with a catalytic acid or a catalytic base.